In our last class, we started taking a look at lists, and we arranged the list in an array kind of manner. And we said the array is great for working with the list, but my array is static, meaning I can't change my memory size. Hopefully I have enough. Hopefully I don't have way too much that I'm wasting it. But there are issues that come in when we're dealing with having a static data type. All right. Well, today we're going to finally jump into what's new and exciting. And as we go through a lot of the rest of the course, we're going to learn about new topics. And then I'm going to say, well, which would be better? Would it be better to work with it in an array in a static environment? Or would it be better to work with it as a linked list? And we're going to build on these classes to do things down the road. All right, so a linked list, again, the word dynamic comes in because we're going to be able to add memory as we need to. Now, remember back when we declared a string, and I said, oh, I want to create a string. It saved the address and it went and found an open spot. Well, we're going to have that kind of idea as we go through here. So the first thing I want to say is we're going to have a new data type, this guy right here, and it's going to be called a node. When we create it, you're going to see the term new node all over the place. Now the node is going to be a struct. Okay, its new data type is this struct. What's inside of it? A value. In this case, we can put double, we could put int, we could put a lot of different things in this struct. But we're just working with one right now so that we can get this up and running and learn how these linked lists are going to work. So I'm going to have one value in here. And the next thing I'm going to have is a pointer called next. And what does that pointer point to? It's going to point to a struct, another list node. And by looking at what you see up here, here's an example of a struct, and it includes a pointer that will hold the value of another node. Okay. So when I get ready to create a new node, I'm going to have my pointer point to null, and it's just going to sit by idly waiting until I do something with it. All right, so in order to get this party started, I need to create a list head. This guy is going to have many names as we go, and it's where I'm going to start my linked list or my chain of these nodes. Okay, right now I have it written as list head. You're going to see it called head. You're going to see it called front. There's a whole bunch of different names we'll use as we learn more and more data types. But all it is the initial pointer that points to a node. Okay, so this guy is going to be like this guy in here. When I declare it, I'm declaring it a pointer as it goes to a node. All right, so what's going to happen? Say I have this pointer and it points to a node and that node points to null, which means it ends. It's done. There's only one thing in that linked list. Well, what can I do? Well, the other day we talked about all these operations that I can do on my array structure that I was using as a list. And I'm going to be able to take a look at those here as well. For example, I might want to append. That means I go all the way to the end. How will I know I'm at the end?
You're pointing to null.
Right, I'm pointing to null. So append would be go all the way to the end where it points to null, and then give this guy, we'll see how to take a look at that shortly, the value of that new node. I might want to insert something. What if I want to insert in the front? This head would point to my new node. Uh-oh. But no, wait a minute. If I do this, I lost the rest of my list. So a lot of times when we're doing things like inserting or deleting, we need to keep a certain order. For example, I know what this guy is, right? But I would like him to point to here first, and then this head pointer point to that new node. And again, we have a bunch of operations that's going to go with this data type. Insert, delete, and so on and so on. Will I need is full, like I had with the array. Thank you, Brady. It's good you're on my screen. Only 4 of you are on my screen. You're on the screen shaking your head no. So I got a response. Yeah, I'm not going to need an is full. Is full. No, I don't need an is full. Would I need an is empty?
No.
Peter's saying no. No, I mean, I could have it, but I don't need it. And what I mean by that is, what is null? Give me a value of null. Null, give me another interpretation of null. Null is the same as 0. It's also the same as, starts with an F. F-A. F-A-L-C. Brady, help me out, please.
False.
False, right. Null is the same as false. So if this head pointer points to null, then it would be false. Okay, so I'm going to take advantage of that in an if statement instead of writing a bunch of extra code for is empty. Just like the other day, people were writing these great big functions for something. And I said, well, couldn't you just do a return, blah, blah, blah. And they're like, oh, crap. And they deleted 7 or 8 lines of code because they were able to do it in just a return statement because it evaluated out as the true or the false. All right, so let's get ready. And I want to start out, I'm going to call it head instead of head node like I had on the other page. And I'm going to declare my head node. My head is a pointer to a list node. You know, going back to chapter 8, we pointed to an int or we pointed to a double or different things. But now I'm going to point to a list node. First thing I want to do is say head equals null. Okay. So what if I started saying, all right, so I have all these functions and I want to start talking about, you know, some pseudocode to get ready to deal with these functions. All right. Well, if I said append, let's see, the first thing I'd need to do is create a new node. That makes sense. I'd need to put the data value in. Makes sense. Part of creating the new node. Then I would check this. If it's empty, head would point to my new node. Okay, we're going to still see how we do that. And see this line with the greater than? We're going to take full advantage of that. Okay. If it's else, I have to go through all the way to the end. And we're going to take a look at how we're going to be able to traverse all the way to the end. All right, so node pointer next is the address of the next node. So remember when I had a node up here, this guy was the next. It was, as part of my struct, this was the value, this was the next. And it will be the pointer of either the next node or the last one will point to a null. Okay, so what do we see? I have a note on here, breakout rooms for pseudocode and diagrams. But I'm going to help you along once again. And, you know, this is me helping. Last class, we had our group project and the patient lived absolute positively last second. What better could we do as a group? Well, next time when we do this, I'm not going to be leading. I'm going to say, here you go. And one or two people are going to have to step up. Was it good having the header file first?
Yeah.
Yeah. I mean, the header file was extremely important. Once we had that, you all knew what functions we needed, what the names were going to be of the different members and member functions. And from there, you could then divide and conquer the whole program. Okay. So I think creating the header file was one of the more important things. Using the discussion board, good or bad?
Yes.
I'll
Good.
take, I'll
Good.
take the yes was good.
Yeah.
A quick, easy way to access it. I know in 161, you did a little bit of this, and some folks were using the chat and cutting and pasting. Just another option to keep in mind. Okay, so before I send you into these breakout rooms, I want to start with, okay, so I'm, each room is going to write some code for insert and for delete, easy for me to say. So if I take an insert, the first thing I need to do is find out whether this guy is empty or not. Okay, if he's empty, I know head goes to null. If not, that means I have something that looks like this. Now, here we go. I'm drawing the picture. I'm drawing the picture over and over and over. All right. So the first thing I need to do, this is the habit I'm trying to get 161s in right now, is what would my test data be to insert? Go ahead. We did a little bit of this the other day. What would be test data for insert?
One.
One. Keep going.
5.
Well, 5's already in the list. We're going to hope there's no repeats.
6.
A 6. I'm okay with that.
25.
25. Have we sort of tested everything we want to test?
What about 0?
0. 0 kind of falls in the category of 1.
Okay.
It would be less than here. All right. So what kind, so now I have my test data and I'm going to go, all right, so I'm going to start by creating a new node, create new node. And again, I'm just starting to chat some things down, create new node. And, so now I'm in my drawing world, I'm going to say new node points to something that looks like this. And it goes to null. And the number I'm putting in is 1. So my new node, I don't need it. That makes it look like it's a pointer. Here sits my new node. It's a 1. Well, if it's empty, like up above here, I'm just going to say head gets the value of null, right? If it's empty. But if I'm inserting into an empty list, how do I insert into an empty list? Well, I'm up here. I want to insert into an empty list. I'm just going to say head gets the value of, means points to new node. And I would be done. And I would be done. Okay. So before we go any farther, I need a little bit of help of how I want to draw these up. Because down here, I'm thinking I'm going to have to be able to traverse through. And as I traverse through, I need to take a look at my 1. And as I go through, if it's less than the value, then I would insert it. So if my new node was 1, it'd be here. I'd need that to point there and head to point to my new node. If it's out here, I need my pointer to point to here and the one before to point to this. So what I need before I go on is a little bit of a look-see of how I'd write some of these. And I lost my page that I was about to pull up. And I'm looking at something along the lines of this. All right, so now I'm in the book and I'm seeing things like, okay, so, oh, come on, go straight. There we go. For example, if I want to do append a node to the end of the list, I'd create a node, store the data in the node. If there are no nodes in the list, I would make it the first node, good. Else I'd traverse the list to the last node, add the node to the end. Well, that is in fact pseudocode, but that's kind of weak pseudocode. We're going to look to improve that a little bit. So here's what append may actually look like. Oh, my camera must be goofy. There we go. Okay, so I have a method called append node. I'm bringing a value in. This is going to help us with insert. Let's see. I create a new node, a pointer to a node, and I have a temporary, another pointer to the node. The first one's going to point to the new node, and this comes down and it's going to click with all of this. Okay, this is a new node I'm creating. I'm going to point to the node. I'm going to come in here. New node equals new list node. New node's value. Remember I said before the dash greater than sign we're going to use. So this is how I reference the node's value. And I assign it a value. This is how I represent a node's pointer. And I assign it a value. Okay. So far, so good. All right. So let's take a look a little bit more code before we jump into groups. And oh, look there. If not head. If not head. Wait, head is false, right? So the not of false is true. So if head points to node, or excuse me, if head points to null, it's false. But the opposite, which means the list is empty. So if I write it as if not false, which is true, head gets the value of new node and I'm done. I inserted my new node, right? Head's now going to point to new node. Otherwise, I have this temporary pointer, gets the value of head, and I'm going to go through while, again, I'm checking for true and false here. I go through and I'm going to traverse all the way through so that I'm finally going to stop where node point. So I'm going to have a list, right? And I'm going to have a pointer that keeps jumping. So right now it's here, then it jumps over to there. And the way it's jumping is node pointer gets its next. So right now node pointer is pointing to this node, right? But it's going to get the value of that node's next. So now it will point to here. Again, I have a temporary variable that's a pointer that points to a node sitting right there. Okay, but instead I'm going to give it the value of this guy, this address, right? This guy's pointer. So node pointer, that's this guy, is now going to get the value of, well, right now it's pointing here to this address, but I want to get this address. So it's going to get the value of node pointers next. When I get to the end, node pointers next gets the value of new node. And as we know, new node points to null, so that would be the end of my list. Uh-oh. So what I'm going to have you do is get into groups, use that same kind of idea, and see if you can write insert, see if you can write delete. Again, if it's empty, there's nothing I can delete. I just display a message. If I'm getting ready to delete, again, this is habits that I want you to get into. Just like, when you actually do this, what's going to happen? Give me some test data. That's a yawn.
5.
3, good. 5, good.
20.
14, good. 15, good. 20, good. 21. So when you're creating an algorithm, it's best to keep all of this test data in mind so that when you're writing the code, you make sure you cover all your bases. I went in the beginning, I deleted the first node. I went in the middle with the 14, so I know I can stop if I get to that point. I deleted the 15, which is one in the middle. I need to figure out a way to delete the last one and to delete something that doesn't exist. Trust me, it seems really, really hard right now, but as you start going through, you're going to see some things start to happen that all of a sudden it's going to get a lot easier. Questions? Breakout rooms. We have 13. I want to do 4 rooms. 3 rooms makes 1 room with 5. I don't want 5. Everybody understand what you're doing? We're only going to do this for about half an hour and then I'm going to call you back.
Are we just doing pseudocode for this, or
Yep.
are we actually trying to do real code?
No, I just want you to do pseudocode. Not what they did on the other one, but maybe write it a little bit more like the actual language.
All right, thanks.
Hmm? Here we go. What time is it? It's 10 o'clock. So by 10:30, I'm going to pull you all back and then we'll talk about it for 15 minutes. So working on displaying this list, 10 pointer gets the value of head so that it points to the first one. While 10 pointer is true, that means it's pointing to something. It's not pointing to null. Nice little clean loop. Clean loop. It has an initial value. It has a check. And what else is it going to need? An update or an increment. So now I want to move this guy to the next one, which means I don't want 10 pointer to point here. I want the pointer that points there. And what is the pointer that points there? Well, right now, this guy is temp pointer's pointer. It's the name of whatever's pointing to this node's pointer. So temp pointer is going to get the value of temp pointer's pointer. So that's this, which means now temp pointer is going to point to there. Print out the value. Temp pointer now gets the value of that line. So it moves over to the next node. And it's going to keep moving over node by node. So a simple example of what you're doing with insert and delete is what you see here. We may have to create a temp pointer. Use that to move through. There might be situations where this can be solved using 2 pointers, 2 temporary pointers. Okay. But right now, hopefully you're writing insert and you see if it's empty. If it's not, you're getting into some kind of loop. But I'll tell you, you'll come to me with a problem and I say, okay, draw the picture and I'll look at it and I'll never hear from you again. Because as soon as you start drawing the picture and doing these things, it's going to make a lot more sense. Questions? Okay.
rest of it.
Essentially, yeah. I mean, this just seems like a different way of doing like another array and vector to me. If that's what it's supposed to be, I think.
Space. All right,
Nice.
so I'm back now. So we're taking a look at this, and one of the things we said, is it empty? First of all, if it is, we insert it and done. So I took care of that right away. I created my new node. My function insert name is going to be bringing a value in. So when I create the new node, I'm going to have to put that value in here as well as point to null. Right? So if it is in fact empty, and we said if head points to null, that's false, then none of that is true. I can let head equal new node and I'm done. First case out. All right, second case was what if I wanted to insert one? So what I did was something along these lines. Okay, if head's value, right now, what is head's value? Here's head.
Null.
Head's value is
5.
5. Okay, head's value. That says go to the node this is pointing to, and what's the value in that node? Same as what is new node's value? Okay, or the number I just brought in. If head's value is greater than my new node value, then it now needs to become the first thing in the list. Now, remember I said steps are important. New node's pointer, which is right here, now has to get the value of head. It would have to come up and get the value there. Then I would say head gets the value of new node, so it now would point to there. So head would go to 1, which would go back up to 5 and keep going in my list. Check. It was empty. Check. Test data 1. Check. Test data 6. Oh boy. Okay. So now I need to keep going through the list. And let's say inside of here, instead of the 1, I have the 6. So it wasn't empty. It didn't go before the first one. So now I need to figure out a way to traverse through. I'm thinking the first thing I need to do is get a temp pointer so that it's going to let me traverse through. Okay. So yeah, this is still, some pseudo code, some real code. Like I said, I noticed some of you were typing. I need to have this picture. So hopefully somebody was drawing as well as you were typing. So right now, temp pointer's value, I know is less than new node's value because I went through the if, I went through this if, and now I've fallen down into this else, and temp pointer gets the value of that node. All right. So now I need to find out if somehow or other this value 10 is bigger than 6. Because if it is, I need to insert it. All right. So right now I'm pointing to temp pointer. How can I get that 10? How can I get the value of the next node? Well, one way might be to get another temporary variable and put in to point to this so that I have 2 variables to work with. Another way is what I have down here. Temp pointers value. Temp pointers points to here, but its pointer points to there. So that guy's value would in fact be 10. So that way, if I find out that this is greater than the 6, then I need to have this guy get that line, which is temp pointer's pointer. So new node's pointer would get temp pointer's pointer. Temp pointer would get the value of temp pointer's pointer would get the value of new node. Well, I need to make a note of that block of code, right? I'm sitting here with temp pointer. I know I want to insert that. You know, again, I'm just scribbling notes all over the place as I'm trying to build code. Right now, I just said if, so if temp pointers value, if temp, I need another piece of paper. Come here. I'm going to do this. If temp pointers value, like I said, right now that would give me a 10. If temp pointers value is greater than new node's value, if that's the case, that means I want to insert the 6. Agreed? Okay, so how do I insert the 6? Let's see. Somebody tell me. I forget what I said. Where would this new node need to point?
Is it temp pointers pointer?
So let's see. You want new nodes pointer is going to get the value of temp pointers pointer. Temp pointers pointer points to that 10. So this line of code right here just linked me up there. Okay, what would my second line be? Well, I need this guy to now point to my new node. I want this guy right here to now point to 6. What is this guy right here?
6.
Well, no, but this guy right here in this block, he is a pointer. I want
Yeah.
that pointer to now point to this new node's address. How do I reference that guy right there? He is temp pointers
Dot
pointer.
next.
Yeah, temp pointers pointer. Okay. Yeah, we should be using the word next instead of what we were doing before. I'm using the word pointer, but yeah, I think next would actually, thank you, whoever just said next. You know, how have we declared? So this would be temp pointers next, you know, and again, it's whatever we call this guy in here. Temp pointers next. That makes a lot more sense. Thank you. Node pointers next equals temp pointers next. And now temp pointers next would get the value of new node, because new node is a pointer pointing to that node. Questions? Now, that is just a side block of code that I wrote over here for when I'm ready to insert. Now I need to figure out when to insert. So I'm going to have to be able to traverse through with some sort of while. I mean, I could do a flag in here of found, which means I inserted it. So I could do while not found if I wanted, but I'm also going to have to keep track of getting to the end, you know, and how I'm going to work all of that. Jump to D2L. I think I gave you code listing for chapter 8.
Chapter 18.
18, I'm sorry, thank you. Chapter 18. You'll see code listings there. Ah. Why didn't you just give us this in the start? Because I don't think you would have understood it in the start. I want you to take a look at 18.4. Oh my. If you load up 18.4, 18.4 is a demo that does all kinds of stuff for us. But what do I need in 18.4? I need that numbers.list. I need the numbers.list. Okay, and if you start taking a look at numbers.list, you'll see should be line 69 in the, I'm guessing it's in the implementation file. I didn't pull mine up. But all of a sudden, we go through and, lines 76 and 77. Somebody tell me if you're seeing the same thing. I hear a voice clearing. I'm looking at numbers.list, not the header file, the .cpp file right now. We're almost out of time. There's so much I wanted to
Yeah, I
do.
see the same thing.
You do?
Yeah.
Okay. So if I share screen and I share, where is it? Oh, that's a project. That's something else that's up from before. Okay. So was it line 69? Yeah,
Yeah.
under insert. I have a bunch of, oh, look, they have a temporary pointer called previous node. There's lots of different ways to this. They have a pointer to traverse through the list. So it looks like they use two different pointers. We only use one because we use 10 pointers next, or and went through that way. Here, if not, oh, we did that. Woohoo! Head points to the new node. The new node's next points to null pointer, which we probably should have put up here when we declared it. But then they go through, there's their while loop, and they're using prev and next. We only used one pointer to traverse through. But yeah, it starts to be, some interesting code. Hopefully, if you look over it now after what we've just done in class, you'll be able to understand it a little bit better. Okay.